Welcome back to your free Windows 7 training, available free of charge. In this video, I will look at the Internet Protocol. The Internet Protocol was first developed in the 1970s as part of a number of defense research projects. The idea was to build a decentralized network that would still operate when parts of it were damaged by war. The Internet Protocol consists of a suite of protocols that make it work. At the operating system level, first of all, the type of service is selected. The service is not part of the IP protocol, but uses the IP protocol to communicate on the network. For example, you may find services such as HTTP, DNS, and SMTP at this level. When software uses the IP protocol, it must first decide if it is using reliable or unreliable transmission. Reliable transmission ensures that packets are sorted so that they are delivered in the same order that they were sent. Reliable transmission also checks to see if the packet arrived. If the packet was lost in transmission, another copy of the packet is sent. If reliable transport is selected, it uses a protocol called TCP, or Transmission Control Protocol. In some literature, you will see TCP/IP. For many years, this is what was referred to when talking about the Internet Protocol. In recent years, with IP version 6 becoming more common, the TCP bit seems to have been dropped, and the whole suite of protocols is now just called IP. When deciding what connection you want, you also have the option to use unreliable transmission. This is called UDP. When using this option, there is no guarantee which order your data will arrive in, or even if it will arrive at all. TCP and UDP sit on top of the IP protocol. The IP protocol is divided up in version 4 and IP version 6. So this brings up the question, when an application on your computer communicates on the network, which protocol does it use? When you have a computer that has both IP version 4 and IP version 6 protocols enabled, Windows will automatically select which protocol to use. With Windows Vista and above, Microsoft preferences the IP version 6 protocols over the IP version 4 protocol when it is not clear which one to use. In most cases, the IP address used will determine which protocol to use, but in other cases, for example, when you send a broadcast out looking for the other computer, Windows will try IP version 6 first. This is why even if you don't use IP version 6 on your network, you should still leave it enabled. Now that you understand about the IP protocol, let's have a look at how to configure it on Windows 7. To modify the IP protocol settings, first open the control panel from the Start menu and select Network and Internet. To configure your network settings, next select Network and Sharing Center. One of the new features introduced in Windows Vista is Link Layer Topology Discovery. This technology allows Windows to create a pictorial map of your network. This computer is only on a small training network, so at the top you can see the computer is connected to the domain training.local and to the Internet. On a large network that supports this technology, you could see routers, switches, and other network devices. To see which network adapters are installed on your computer, select the option Change Adapter Settings on the left-hand side. I could also select a specific adapter shown on the right-hand side, such as Local Area Connection. But by selecting Change Adapter Settings, this will show all the adapters on the system, as well as VPN connections and adapters that are disabled. If I now open the properties for my local area connection, I can set the IP configuration for this adapter. In the properties of the network adapter, you can see all the client, services, and protocols that are bound to this adapter. The top one is the client for the Microsoft Networks, which allows the adapter to connect to network shares and access other Microsoft services such as Network Neighborhood. Also, third-party clients could be added here. Those listed next are the Quality of Service Packet Scheduler and File and Printer Sharing for Microsoft Networks. These are services that interface with your network adapter. The QoS service attempts to manage your bandwidth more effectively so that time-critical services are not affected while large downloads are happening at the same time. File and printer sharing allows your files and printers to be shared on the network. Next, you have the protocols used on the adapter. The IP version 4 and IP version 6 protocols will always be in here by default. To start with, I will look at how to configure the IP version 4 protocol. All you need to do is select it and press the button Properties. By default, the protocol will attempt to automatically configure itself using DHCP for the IP address and the DNS servers. In some cases, for example, what is quite common with servers, you can configure a manual IP address. In the next video, I will go into more detail about IP version 4 addresses, so don't worry if you don't understand them just yet. In this case, I will configure a private IP address and set a DNS server located on this network. If you need to configure more settings, select the option Advanced. In the Advanced option, you can configure items such as multiple IP addresses on an adapter. Down at the bottom, you can configure items such as multiple gateways if your network supports them. A gateway provides an exit point for your network to reach other networks or even the Internet. If you enter in multiple gateways, Windows will use one of the gateways until it fails. When it fails, Windows will switch to another gateway. Windows will not switch back to the first gateway if the other gateway comes up again or load balance between gateways. For this reason, if you set up multiple gateways on your network, make sure that both gateways can access the same networks. On the DNS tab, you can set up which DNS servers your computer will use to resolve names. On the Previous tab, you can configure 2, but if you want to configure more, you can do it here. The options below determine how a DNS address will be resolved. By default, Append Primary and Connection-Specific DNS Suffixes is selected. To demonstrate this, if I open a command prompt and ping DC1, you will notice that training.local will automatically be added to DC1. The domain is training.local, and thus this suffix will always be added automatically when attempting to find computers. The next option, Append Parent Suffixes of the primary DNS suffix, does not apply when using a domain like this one. Instead, imagine a domain like testing.west.training.local. When you attempt to resolve a DNS name with this option on, the operating system will attempt to resolve it with the full DNS name of testing.west.training.local. If this fails, it will drop the leftmost part of the DNS name, in this case testing, and try again. If it fails again, it will drop west and try training.local. If this fails too, it will respond that the DNS name could not be found. The next option, Apply these DNS suffixes in order, allows you to customize the domain suffixes used. For example, just say this computer was part of the domain example.local. Later on, a network called west.example.local was added. I could manually add both of these domain names, and thus any resolve request would check both these domains for that computer. I could even add additional DNS suffixes such as training or testing networks. The next option, DNS suffix for this connection, allows you to set which DNS suffix you want to use for this connection. By default, the domain name will be used. But for example, just say you had a wireless access point. You may want to call it wireless.example.local, or if using a VPN connection, give it a special name. This would allow you to determine which type of connection was being used to connect to your network. The option Register this connection address in DNS means that this computer will attempt to register its name in the DNS server using dynamic updates when it connects. By registering your computer in DNS, It makes it easier for other computers on the network to find you. The last option, if ticked, will register the DNS suffix for the connection when the computer is registered in DNS. The last tab is the WINS tab. WINS is an old name resolution system that was used before Windows 2000. Some legacy applications may still require a WINS server on your network. However, nowadays these legacy applications should be rare. The option lmhosts lookup means that a file called lmhosts will be read, and any names in this file will be used for name resolution. Nowadays, if you need to configure manual name resolution, you should more likely use the other file called hosts. But for backward compatibility, the lmhosts file is still here. The last setting is the NetBIOS settings. NetBIOS is an old flat naming standard in which computer names could be a maximum of 15 characters. Old legacy applications may attempt to look up computers using this system. I would recommend leaving the setting on the default, which will use the DHCP server to configure it. If you need to enable or disable it, you can do so on the DHCP server. Otherwise, you can manually enable and disable it. Be warned, if you manually configure it on each client on an enterprise environment, you will need to visit each computer to change it if you change your mind later on. That's it for IP version 4. If I go back and select IP version 6, you will notice the options are pretty much the same. You can configure the IP address to be obtained automatically or manually. The only difference is the addresses that are used. I will go into IP version 6 addresses in a later video. In the advanced section, you can see the options the same as you can in IP version 4. You can configure multiple IP addresses, gateways, and you have the same options available for DNS as you did for IP version 4. That is it for our quick tour of the Internet Protocol. For more videos, study guides, and exam questions, make sure you visit our webpage. In the next video, I will look at IP version 4 in more detail and how to deploy it on your network.